Hello everyone. Yesterday I had some technical issues, so I wasn't able to record. My Teams wouldn't open. Now it's opening, so I'm able to record now. Okay. All right. So where we left off, actually it was somewhere here. We talked about the domain graph. We did this example. Okay, we worked on representations of functions. This is our second lecture. Okay. Let's see which example. And we talked about the vertical line test. We gave a couple of examples. And we did this example. We talked about the piecewise functions, how they are, how we draw the graph of. Okay, we did this example. We talked about this example, if you remember. Okay, we have not talked about the absolute value. Absolute value is very important. As you've seen here, whatever inside this absolute value, either negative or positive, we are going to always have a positive or zero outside taken the value. For example, absolute value of -3 is going to be positive number 3. Absolute value of 0 is 0. Square root of 2 minus 1, absolute value square root of 2 is approximately 1.4. 1.4 minus 1, it's a positive number, it's close to 0.4. So therefore the absolute value is equal to square root of 2 minus 1. Okay, and let's see. Right, what is absolute value? You can see the definition here. Whenever a is greater or equal to 0, the absolute value of a is going to be a. Whenever a is negative, it's going to be negative a. We discussed this in our previous classes, and most of you knows about that. So how are we going to draw the graph of this? The graph of this is like a V-shaped. You're going to see that. You should always remember that this function is V-shaped function. As you see here, usually if this was an absolute value of x, if it was x, then we would just draw a straight line like this, right? That's passing through the origin. But this is absolute value, so what we are going to be doing is we are going to just reflect the part that's below the x-axis here, and then just reflect it along the x-axis, and we get this. Okay, so this is the V-shaped absolute value x. And let's see. Okay. I'm going to skip this example too. About the symmetry. The function that we work on could be symmetric with respect to the x-axis or with respect to the y-axis. So whenever the function is symmetric with respect to the x-axis, we call it with respect to the just a sec. Just one sec. So depending on, right, okay, if the function is symmetric with respect to the y-axis, then this is called an even function. Well-known example is x squared. Y is equal to x squared is an example. Here they give the example. Okay, this is not x squared, this is something else. Okay, so here x squared, but the picture is not x squared. Okay, x squared, I mean this is x squared shifted x squared, because x squared is usually like this. Okay, so I have let's see whether you can see this here. I have the board here. I can draw y is equal to x squared. So can you see that? Not really, right? Not the best. y is equal to x squared. So this is y is equal to x squared. If I want to show you, so this is y is equal to x squared, you see. Alright, so actually this is not the best, probably. I'm trying to find ways to write it for you, okay? So I'm gonna make it a little bit smaller then. Let's see. I'm trying to make you see it. Maybe I should do it like that. It's bigger now. You won't be able to see it as much. You're gonna see a little bit of me, but I want you to see the screen. Okay, now if I move it away, then you can see it. Y is equal to x squared much better, right? Okay, so this is y is equal to x squared. Alright, so alright, so let's move back to our page. My other question is, can you see it? Can you see it? Let me see. I'm gonna make it a little bit more bigger. So that you can see it, okay? Alright, so you're not gonna see me anymore, but you're gonna see the page anyways. Okay, maybe it's better like that. Alright, so so this is our even function. Y is equal to x squared is even. And this is symmetric with respect to the y-axis. We have an odd function. So whenever it is symmetric with respect to the y-axis, we call it even function. Okay. If the function is symmetric with respect to the origin, we call it odd function. For example, x cubed is an odd function. Okay, it is symmetric with respect to the origin. So this is x cubed. All right, this is x cubed, and it's symmetric with respect to the origin. See, if you take a point here, and if you take the distance, draw a line to the origin, and you're gonna see, you're gonna be able to find a symmetric point here. Okay, so the same picture you have here is drawn down here. Okay, it's a symmetric with respect to the origin. That's what it means. Okay, all right. All right, next. So next, what do I want to say? This is our symmetric function. Here are some examples that we want to discuss, whether they are even, odd, or neither odd, or even, neither even. Now, how do we do that? We won't be able to draw the graphs of these. So what we are going to do, we are going to go back to the definition. If we have a chance to draw them, then we can just look at the picture, the drawing, and say it is symmetric with respect to the y-axis, so it is even function. It is symmetric with respect to the origin, that it's an odd function. However, we don't have that choice. So we have another tool, which is the algebraic tool. So in order to be even, we have a definition actually. F of negative x is equal to f of x. So what you're going to do, you're going to check that for these functions. And this is for evenness. And for oddness, we have f of negative x is equal to negative f of x. So we are going to check that. Okay, how do we check that? So we are going to check it step by step. So if this is f, we are going to look at f of x, f of negative x. We put, instead of x, we put negative x in here and negative x in here. Negative x to the 5th power is negative x to the 5 and negative x. All right. And then of course, this is negative x to the 5, negative x, and you factor out negative. And what do you see? You got that this is negative f of x. So this shows that actually this is an odd function, because odd function has that property, f of negative x is equal to negative f of x. Okay? Because of that, it's an odd function. On the other hand, all right, It is written somewhere here, you don't see probably. Let's see whether you see it. Okay, because of this you don't see it. Okay, I will try to move this. I can't. I want to just move this or hide it. If I can hide it, doesn't allow me. Okay, anyways, so you believe me that this is an odd function. Next, we are gonna do part B. Okay, we are gonna do part B. In part B, it is g. G is 1 minus x to the 4. But we are gonna look at g negative x, and instead of x we put negative x. So 1 minus negative x to the 4. 1 minus, so negative x to the 4 gives you x to the 4. 1 minus x to the 4, which is g. So g of negative x becomes g of x. So this is going to tell you that this is an even function. Okay, g is even. Let's check h. What was h? H was 2x minus x squared. Let's go back to the answer. Okay, so whenever we see whenever we see x, we are going to substitute that with negative x. So 2 times negative x minus negative x to the second power is going to be negative 2x minus square of this is positive x squared, negative 2x minus x squared. Now we factor out negative x, however you see that we don't get h of x, and we don't get negative h of x as well. Okay, because of that, it doesn't satisfy either of the properties. So we are going to say it is neither even nor odd. Okay? Alright. Next, by looking at the graphs, maybe we can say something about the symmetry. Like if you look at the first graph is like x cubed, right? Does it say? Yeah. So this is symmetric with respect to the origin. So we are going to say this first example A is an odd function. Okay. Let's look at G. G is symmetric with respect to the y-axis. Whenever a function is symmetric with respect to the y-axis, it is an even function. And how about H? The graph of H, the graph of H, actually these are the graphs of the example that we had. And the graph of H, as you see, it is neither symmetric with respect to the y-axis nor symmetric with respect to the origin. Because of that, it is neither even nor odd function. Alright? Okay. Next, functions could be increasing, decreasing. So what does it mean? Look at this graph. So if you go, increasing means actually if you go to the right, if you go along the x-axis, if your y is also increasing, going up, then this is an increasing function. If you look at the arc, the graph between A to B, whenever I move to the right, y is going up. So from A to B, the function is increasing. However, from B to C, it is doing the opposite. Whenever I go to the right along x-axis, the y value diminishes. It gets smaller, right? It goes down. So because of here, between B and C, the function is decreasing. On the other hand, between the points C and D, the function is going up again, so increasing. So we are going to say on different intervals, for example, from little a to little b, okay, it is increasing. Little b to little c, it is decreasing. Little c to little d, we have those points here, we don't see it here. It is increasing, okay. So mathematically, actually, we can write it down. The formulation as follows. This is the formal way of saying it. So whenever x1 less than x2, f of x1 is less than f of x2. This is increasing. So whatever the x's, however the x's behave, f of x's also behave the same. So this is increasing. And If it is opposite, then we call it decreasing. Look at this picture. This is the graph of x squared, well-known function. So if you look at to the left of 0, the function is going down, so it is decreasing. Okay? If you look at to the right of 0, the function is going up, so it is increasing. So we are going to say f of x is equal to x squared is decreasing on the interval negative infinity to 0. Okay, close it. And it's going to be increasing on the interval 0 to plus infinity. You can close 0 no matter what. I mean, it doesn't really cause any problems. Okay, that's it. So these are increasing, decreasing functions. Now I'm going to pause. Actually, I'm not going to pause the recording, but I'm going to share my second slide. Or maybe I should, yeah. Just give me a couple of minutes, okay? Thank you.